This is the 4.2 Day 2 video for your notes. On Day 2, we started out by reviewing how to use point-slope form if you were given 2 points in order to find slope-intercept form. And then we moved on to some application problems. So we had a word problem is where we started. So here it says the student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of foam hands. So after we talked about the actual scenario, we talked about how to tell if something is linear. So over here, I made you guys a note to help you remember that in order to tell if something is linear and you're given a table of data, what you're looking for is that constant rate of change. So the first thing we did is we looked at the pattern of what was happening as you move from each x value. Remember, we talked about the number of foam hands would have to be your independent variable, so that's going to be your x. And we noticed that for every little set of data, it was going up by 2 every time. Then we looked at our cost. Our cost is our y value. Remember, your cost is dependent on the number of foam hands that you purchase. So that's how we knew that it was going to be the dependent variable. When we looked at our pattern here amongst our y values, we noticed that it was increasing by 12 every time. So because I noticed that it was going up by 2s every time on x and up by 12 every time on y, we knew that this was indeed a linear function because there was a constant rate of change. Okay? So then we kind of reviewed the fact that rate of change is just another way to say slope. So if I'm trying to write a linear model, which remember a linear model is just an equation, the first thing I'm going to need to do is go ahead and calculate that slope. So we can find slope by doing change in y over change in x. Our change in y here is equal to 12. That's because that's the amount that the y values are increasing by every time. And our change in x we found is 2 in our table of values. Therefore, we know that our slope must be equal to 6. Once you have your slope, then you can use one of the points from the table and your slope, and you can use point slope in order to find the actual equation. So remember, point slope is y minus y1, which in this case is 34, equals the slope, which is 6, times x minus x1, which is 4. Notice that I circled the point that I'm using and I circled the slope that I'm using. That way I don't mess up any of my data. Okay, I know where I'm getting my values from. So then from here, I am going to solve for y to get this in slope-intercept form. So that means I need to distribute the 6, and that's going to give me y minus 34 equals 6x minus 24. And then I'm going to add 34 to both sides. When I do that, that's going to give me y equals 6x plus 10, which is my equation. Now, since it did ask for you to write this as a function of the number of foam hands, if this was a multiple choice test, they may have it written as f of x equals 6x plus 10. But hopefully you guys at this point are comfortable enough with function notation to know that f of x is the same thing as y. Okay, so there was actually another problem on our notes that we closed with as far as the word problems. You guys did one on your own, but I am going to close the video here, and if you have any questions, then we can work that example during tutorials. You guys have a great day.